but did anyone wear a thing like this? This Hawaii Day? Could you guys at least, you did so good at uh, homecoming. Tomorrow, does anyone know what tomorrow's supposed to be? Sports Day. Wear a sports shirt. What's that? That's not. No, it's not. Come on. Yeah, it was an accident. All right, fine. All right, but tomorrow's a sports. Come on, we all have a sports shirt, right? And then Friday is pink out day. So let's do it. Come on, let's get that spirit up again. It's Red Ribbon Week, so we're that's no drugs. Drugs are bad. Okay. All right. No, not stop sharing. Hide. Okay, here we go. Okay, so back to this question. Get my Hawaiian shirt out of the way there, or move me up there. Okay, remember what we made year 1990? We made that year what? Zero. Okay, first of all, let me write this. Anytime you hear a real world question with data is exponential, this is the general form. I'm going to go back and forth. It could be this or it could be this. This is just function notation. What does P stand for? What does P stand for? Oh, come on. Population. All right, come on, guys. And then I think I still had a B raised to the T. So it's one or the other. I just like going back to the Y equals A times B to the X. It's just basic and simple. So it's either or, though. Okay, now my question is, what is A? Let me let that sink in for a second. You all should know what A is already. All right, here we go. 3, 2, 1, go. Ah! What did we make year 1990 yesterday? Year what? Zero. Input, say it. Output. So the input yesterday was 0, comma, and then I think it was like 400,000 was the thing. All right, so now I'm going to ask you one more time. What is A in this question? 3, 2, 1, go. No. So I plugged in 0 for 1990, 0, comma, 400,000. For the love of dog, in this chart of values, 0, comma, what? What do you see? 3, 2, 1, go. 3 halves. So the A value is 3 halves. This is why a chart of values question is a lot easier. Okay? Because usually they do give you the initial value sneakily in this chart of values. So this is not necessarily years, although we could have argued it could be years because 1980 was year -10 then, and it could actually be calculated. You could take a guess. What would have the population been 10 years ago? Plug in -10 into your formula. It actually would work. But anyway, now you had what we did yesterday. We had to plug in 10 for X and then the population in 10 years for Y to find what B is. What do you think you should be plugging in another data point here? That would be a lot easier. So would it be -2, comma, -1, comma, 1, comma, or 2, comma? Which one would be the easiest? 3, 2, 1, go. 1, comma. You got it right, not the other period. They did not. I want to plug in the 1, comma, because what's B to the first, everybody? What's B to the first? But just B. If I put 2, comma, then this would say B squared, and this would say 3/8. How do you solve for B squared? What would you have to do to both sides? Square root. B to the first, I don't have to do anything other than solve for it. And how do I solve for 3 halves times B? What do I multiply both sides by? Oh my gosh, I got no one to say anything. A senior in this curriculum of Lockport. You multiply by the reciprocal, all right, which is 2/3. All right, 2 goes into 4 2 times. 3 goes into 3 1 time. All right, so B, let me turn back to red. I just wanted to see that, equals a half. And then I could prove that this is the equation that matches this data by input. Say it. We can check a couple other data points. So A, you might want to write this as times B, and I guess I'm using X instead of T. Yep. Raised to the X. I'll check one of them. This one's easy to check. 2, comma. 2. When I take a half squared, that becomes a fourth. really hope I'm speaking math language that you understand. The ability to square a fraction is just square the numerator, square the denominator. 1/4 times 3 halves, 4 times 2 is 8, 3/8. Check, baby, 1, 2, 3. So I'm inputting, outputting, just making sure my equation matches some other ones. If I plug in -2 for x, here's what happens. 1/2 to the -2 is actually 2 to the 2nd, which is 4. 4 times 3 halves, 2 goes into 4 twice, 2 times 3 is 6. So I can actually evaluate that as well without having to write it down. I really hoped all of us would be able to be that way starting in August, being able to deal with those numbers. We actually did a question like this already. It's just San Jose instead of Columbus. And a lot of things I'm going to do today are very similar to what you had to do yesterday. Maybe another reason why I won't collect that homework, maybe another day to clean that up. Maybe go ahead and write this down, but really this is not much different. And this is technically you're now in 3-2, but part of 3-2 is almost exactly the same as the thing that we did in 3-1. You don't have to care about the sections. The homework's going to be in 3-2 today. And you should say to yourself, this looks almost identical to this formula. P of t equals P sub 0 times some b value raised to the t power. I accidentally put x in the notes and caught it for the first time in years. And all this is saying is, this is the only thing that it's saying. And this is what all the rest of this stuff down here that I'm not going to let you write because I'm going to say it. It's a very simplistic concept. First of all, when you multiply something by 1, does it change? Yes or no? 3, 2, 1, go. No. What it's saying is this then. If your b value is bigger than 1, then you have a growth or decay. 3, 2, 1, go. Growth. When you multiply by higher than 1, things go up. When your b value is smaller than 1, then what do you have? Decay. Because when you multiply by a number smaller than 1, things go down in value. So that's what it's doing. It's saying, okay, let's look at this b a little further and analyze what's really happening. So if I have a growth situation for growth, I'm embarrassed that I'm even writing this down. Then b is 1 plus some r value, some rate that's making it go higher. If it was decay, then you'd have some b value that is 1 minus some rate, a negative rate that's knocking it below 1. Very simplistic concept. I'm embarrassed that I even wrote that up there. Okay? All right, so now here's the game. Growth or decay. Got 2 cities, San Jose and Detroit. And then that's what we can do. You can simply put in your notes, growth or decay. That's it. That's what all this crap says right here. Tell whether the population has X amount of growth or decay, and then find the constant percentages. We'll do that here. Okay, so looking at San Jose, growth or decay. 3, 2, 1, go. Growth. Did I hit play? Yes, okay. For some reason I thought I would. Forgot, I mean. So it is growth. Now here's the thing. This one's easy. But I won't ask you. I'll just do it. What is the growth rate? The rate is actually equal to that component that's above 1, 0.0136. Or 1, I'm glad we weren't doing a test today. That's major construction. I feel like every single year there's construction going on in this school. Just not happy with the way it looks. Or at a rate of 1.36%. And usually for cities, this is per year. We really got to watch your questions, though. The time is built into the question. But usually for cities, it's per year. Okay, Detroit, growth or decay. 3, 2, 1, go. By the way, Illinois is decaying. You know why? This is if not the worst, one of the 2, 3 worst states to retire in, with taxes and all the things that are going on, and politicians stealing from us. It's awful. All right, so a lot of people are jettisoned out of here. So we're decaying. And Detroit, this is truthful. Detroit really decayed when the car industry and their just fell apart. So anyway, but what is this rate? Now this one requires a little bit more. The rate that it decays, technically we should do 0.98 minus 1. But we're going to do this when we attach the word decay on there. We should know that it's a negative rate. So I'm going to say it decays at a rate of, and then I list it as a positive. Can someone do that on a calculator? I asked that last hour. I have 27 students. Not one stinking student did a thing. Not one. Here we are. He's holding his bottle. Looks like you're hanging on for dear life. Don't have your notes again. This is teaching in America right now. Anyone gonna do this for me? Look at you, just holding your chin up. Oh, he's got it. She's got it. Okay. All right. What's the answer? Huh? What? 0.0 what? 142. Sorry. Or, let's put a negative on it. It's a decay, so let's put a negative on it. I should switch these. Let's be responsible as a teacher. Or a negative 1.42%. And I can't help you if you don't know how to deal with percents. You move the decimal twice. I'm done with that. Okay. All right. So I'm going to go back and forth on this. This is why this first example is pretty simplistic. I think I only have 2 more examples after this, so it's nice little day. What happened, sir? Did I put where? 147.2? Wait, where? What? Huh? What? 1.01 what? 1.746. Did you even type it on your calculator? What did you get? I'm so confused right now. I don't know. He typed it. You didn't. I'm very confused what's happening right now. I'm just going to move on. I'm sorry, bud. I don't know what just happened there. Okay, now let's move on. I'm okay. I don't know why that keeps happening. All right. Determine the exponential function. Stop. Okay. The exponential function is y equals, let's go back to the simplistic, a times b raised to the x. Okay. With an initial value of 12, increasing at a rate of 8%. That's a pretty big increase. Okay. So what's A, everybody? 3, 2, 1, go. What? What's A, everybody? 3, 2, 1, go. 12. It says the initial rate, and that's what A is, 12. All right, now I'll be careful. What's B? Don't answer that. I'll get goofballs that just put 0.08 there. What happens when you take 0.08 of something? What does it actually really do a lot? It really what? Goes down. So what do we actually have to put here? It's 1 plus R in this position. And the rate is 8%. And by the way, 8%, fine, I'll enable you and remind you of your 3rd grade how to deal with the percent, right? Because there are a lot of things that keep going wrong that are based off of grade school stuff. So it is 0.08 there, so that's what R is. So understanding that this is 12 times 1.08 raised to the x for this particular formula. Don't be going down now. You're looking awfully comfy. Plus, you don't have your notes, do you? No notes? You just like him? Oh, my goodness. Okay. You got an A triple plus? All right, here we go. What's that noise? All right, I don't want that. I want that hidden. Then we'll bring this back. Okay, here we go. That's fine. What's the matter? What's going on? What's wrong? Huh? What happened? Matt, what's happening? Is everything okay? Oh, I know. I heard something. It wasn't swear words, was it? All right. So, suppose a culture of 100 bacteria is put into a Petri dish. Is that how you say that? How many scientists are there in here? Petri? Okay. Petri? I don't know. Dish, and the culture doubles every hour. Okay, I asked this last hour, and people messed this up. what does that mean the growth rate is? This is kind of a tricky thing. So something doubles. What does it grow by every hour? Not 200%. What's the answer? It's actually, it grows by 100% every hour. My pen is starting to act up here. So that's what the growth rate is. And then how do you change 100% to a working number? You move the decimal 2 to the left. The growth rate is 1. Isn't that weird? But you just said when I multiply by 1. No, that's what we're going to tack on to 1. So when we do this, y equals a times b raised to the x, and no, b is actually supposed to be 1 plus, oh my gosh, this pen, I'm going to lose it, is 1 plus whatever the rate is, then this is where we'll see the doubling. We'll see the 1 plus 1, which is 2. So I know this is great. It's just awesome. I wish we had a test. It would be great. I just learned. Hey, you're in my video, by the way. There's Mr. Stronowski. Hey, anyway, go ahead. We have construction every year at Lockport. We're never satisfied. Yes, she does. Yeah, I saw it. She got the White Sox shirt. Yep. Okay, so anyway, 100 is the initial value. And then 1 plus 1 is 2. There's where the 2 goes in. There's where the doubling is. So if you have a double every hour situation, then yes, the B value is 2, but not the growth rate. The growth rate is 100%. It grows by 100. So that's what you got to understand. And then it is raised to the x power. Okay, so I don't know, probably made that over convoluted, but it's all about what would this be at the end, right? And this is what happens. And it's very easy. Every hour. What happens when I plug in 1? And by the way, times in hours now. What's 2 to the first, everybody? 2. No, 2 to the first, 2. And then what's 2 times 100? 200. So in 1 hour, this doubled to be 200. It checks out what we have going on here. Now, this is just like yesterday. So if you were confused how to do yesterday, this is what we need to do next. When will the bacteria reach 350,000? Now we got to go to our calculator. When I teach you logarithms, then we won't need to do that. We'll be able to use logarithms to solve this. And we do have to type this in y1, y2. So, okay, I already did it. So for the purposes of the movie, I got it all set up. Doubles every hour. By the way, x is now in hours, not years like in a population of people in a city. And then 350,000 is the y2. So I'll give you a minute to manipulate your calculator. Where's your calculator, ma'am? Oh, no, never in math class. Did you type the y equals? Oh, you're not playing along? Yours is bad. Did you not plug it in? Is your battery bad? Not sure. Okay, before you go to graphing this, one more talk about the window. So understand what x is. X is the time in hours. It doubled every hour. And I got to guess, how many hours could this double? How long could it possibly take? Well, it could take 30 hours. What if it's more than that? Then I'll have to go back to this window and change the hours. You got to be able to go back and change the window. But this is for sure what has to happen. You got to get a y maximum that's bigger than 350,000, or else you're not going to see that horizontal line. So we got to make sure we go from 0. And I like 0 to starting with 0 for the mids because it's a real world question. And we'll see the x and y axis on the edges when I hit graph. Okay, so there they are. Okay, and then I just want to tell you, it worked, meaning it does happen in less than 30 days. If you saw this graph like still over here and it hit here and these didn't intersect yet, you just have to extend the day. You'd have to go further on the x. You'd have to add days because it's going to happen later than what you put in there. And then what do I hit on my calculator here for this menu, second trace, which is calculate? What do I hit? Very simple. Intersect. Something really weird happened in my last hour when I hit this. That was not there. It was gone. I couldn't see the cursor, and I started freaking out. And all you have to do is look down here. And if you look down here, look at this Y value. Look where it's at. It's at 678,000. This is why you don't see it. It's up here somewhere. It's off the screen. And all you have to do is hit left until you see it start coming down to that window value of 400,000. That's why I see it now. It says 361,000 there. And actually, for this, all you have to do is hit enter 3 times. The whole first curve, second curve, second curve guess. I really wish they would have gotten rid of that feature. The TI Inspires does something actually more direct, and I wish the newer calculators did the same. But I think they wanted to keep these like the old 83s and make it all, the same kind of situation. What do I want then? Do I want the Y or the X? And the answer is the X. And then I can go to what the other teacher put. I can't get this because my face is in the way. I guess I could have just done that. So one of the teachers put a real nice graph of this over here. That might be a picture from the book. No, I think it might be actually. All right, so it happens in 11.77 hours. And that's approximately if the rate continues at that consistent exponential rate. That's pretty fast. And I won't go into it any further. Obviously, for that bacteria growth, there have to be some checks and balances where that just doesn't keep going. Because, like in like a year, it would take over the whole universe if there was no check in how fast it would grow. But anyway. All right, one more thing, which is actually not really a new thing, but it is a nice concept, and I like talking about it. And you don't have to write all this down; just have to understand it. Radioactive decay, which scientists put it into half-life, so we can compare a bunch of different substances. And I'll talk about that after I read this nice little sentence. Exponential decay functions model the amount of a radioactive substance present in a sample. The number of the atoms of a specified element that changes from a radioactive state to a non-radioactive state is a fixed fraction per unit of time. Process is called radioactive decay, and to keep things like in a commonality, we have done half-life as humans. We've been measure half-life of those things for radioactive substances. So, for instance, all of us are made of carbon. And the thing that remains when we're dead and gone, I hate to go over this with you, is our bones. So actually, when you find a bone, you can measure like the radioactive decay of carbon-14, which I think its constant half-life is 3,000 something years old, or that's how long it takes for half of your carbon-14 to decay into some other element. We can measure and then see how old that bone is. When we have an asteroid that hits Earth or a meteorite, we can pick a certain element that's in that meteorite, which has a half-life of maybe 1 billion years. Some half-lives are actually pretty intense, pretty insane. That's why we can estimate that thing is 4 billion years old at the beginning of our, same age as what Earth is. And that's why we're amazed by that, because all the asteroids and meteors that are in our solar system, we were made by those. And that's like our brothers and sisters out there. It's really true. Earth was made by meteorites and asteroids collecting together and just growing. And it's those same things that are out in space that help make us. So it's kind of interesting that happens. So really amazed by that. That's why we do a lot of stuff with NASA to try to understand ourselves and where we came from. True story. Now I want to hide that. Half-life questions work a little different though. Okay, so you got to really pay attention to this and get this written down. Or not, the guys that are not taking notes, whatever. Suppose that the half-life of a certain radioactive substance is 20 days. Some things have a half-life that are very short. It is true. So we'll just leave it at that. And there is 5 grams present initially. Find the time when there will be 1 gram. Okay, so within that question, it doesn't really tell you what to do. What you have to do is find the equation. You have to find the equation for this in this format. Let me get rid of that. Actually, don't have my pen ready. Okay, so first thing, what is the rate? First of all, is it a positive or a negative? Decay. So what's the rate? Positive or negative? Negative. So the rate is negative 50% or negative a half. So when you start looking at this equation, this is the point of the section. B comes from 1 plus or minus whatever your rate is. In this case, it's a minus. So, but here's what happens again. What happened with doubling? The B became 2. Look at what happens with half rate. The B becomes 1 minus a half, which is what? What's 1 minus a half, everybody? What is 1 minus a half? Oh my gosh. I got it. It's a half. Wrong! I got to go back. I went too fast. I was upset that people couldn't do 1 minus a half. Okay, so doubling 2 goes in for B, half goes in for B when it's a half-life. But here's the problem. I've got to be able to plug in 20 into this exponent because in 20 days, 5 grams will become 2.5. That's what half of 5 grams is, all right? So the exponent is not x, it is x divided by the half-life rate. And the half-life rate happens to be in 20 days, which makes this question in terms of days. So it's always, this isn't always. I should have put this like in more generality. This always happens with a half-life question. So my equation is y equals 5 half-life x divided by 20, and then I can explain it as long as we have some mathematical ability here. Look at what happens when I plug in 20. What's 20 divided by 20, everybody? 1. What's 1/2 raised to the first? 1/2. What's 1/2 of 5? That number I told you already. 2.5. I should have been able to ask that question. The half-life is 20 days. I have 5 grams. What will I have left in 20 days? You should have been able to tell me 2.5. And then what will I have in 40 days? What do I have to do to 2.5? I have to take another one. Half of that. What's half of 2.5? 1.25. Guess what happens when I plug in 40? What's 40 divided by 20? 2. What's 1/2 raised to the second? 1/4. What's 1/4 of 5? 1.25. What I'm doing is proving why this works. Now I can plug in any day that I want, and I will get what the remaining grams will be. And I prove when I plug in 20, truly get a half-life. When I plug in a 40, I get 2 cycles of the half-life going. And that's why I end up with 1.25. Okay, so done with that expression. Going back to the bone, I'm going to look it up. I know it's somewhere around 3,500 years or something like that. For a half-life of a carbon-14, it would be x over 3,500. That's actually true. Whatever the years are, I'm very close. I can't remember what they are. And then I'm not going to the calculator. I already showed you on the calculator. This is what you got to do. All right, and I probably should have, but because of time and we got major construction out there, I can hear them pounding away. Put this in y1, 5 times a half, raised carrots to the x divided by 20. This is way up here. All of it's in the exponent. Make sure you know how to type that correctly and keep that all in the exponent position. And then they asked me, when will this be 1 gram? By the way, when we teach you logarithms, we're going back right to these questions, and we're going to solve with logarithms and not the graphing calculator. It's actually true. This is why we have to do this right now. But I do like it, and I don't mind it. All right, and then notice where this happens. This happens somewhere after 40. So this is the thing where If I left my calculator like this from this question, let me move this up here, and then I type these in here, those two other equations. Oh, fine, I got time. What is it? 5. Nope, that's clear. 5 times, let me do parentheses, 0.5 instead of a half will be faster. And then here's my caret. Caret x divided by 20. Notice that's all in the exponent. That's what I was worried about, the ability to type that correctly. And then type in clear 1 gram. Watch what happens with my graphs, which is not what I showed you on that screen. Oh gosh, I know why this happened. My bad, dogs. What did I also not change? I didn't change my Y window. There's no way in heck I need to be going to 400,000. I need to be going to like 10 maybe, or 8. But I'll go to 10. Yeah, I forgot about. There we go. There's the exponential graph. I wanted to emulate this instead of talk about it in that previous one. Oh, and then there's the horizontal line y equals 1. Oh. Yeah, I think as a human you could see these are eventually going to cross. I just haven't gone far enough. So therefore, I have to go back to my window, and I'm glad the Y window thing happened to me. So I have to go to like 50. I just have to extend this further because it's going to happen further out in time. Now I see more of that classic decreasing or decaying exponential graph. And then I did it. Looks like we have an intersection, and then we can go ahead and find that intersection. Second, calculate 5. Watch how fast I do this. You know what? Who cares? Enter, enter, enter. It's because there's only one intersection point. You don't even have to get close to it. All right? So the intersection happens at 46.4. That is 46.4. And this should make sense. That is at 46.4 hours. Remember what I told you? After 40 hours, you'd have 1.25 grams. So therefore, it's just a little bit further after that. Oh, it's days. My bad, dogs. You're right. Thanks for raising your hand on that. I forgot the label was days. Was our previous question hours, right? This one was in days. Let's go back to that. It was days. Yeah, so my bad. All right, so got it? So hopefully you understand the cycles of having every 20 days. I think I was saying hours in the middle of this question too on accident, so that might have been a problem. Okay, and then I think I've made it super explanatory what you're supposed to do today.